Okay, so what we've done before has come and led to this, word problems. Now, today I had, I'll give you a little bit of a story. A lot of students say, oh, I hate word problems. Okay, can't we just not have word problems? I don't understand word problems. And I think the aversion from word problem stems from all the way from your elementary years. So I won't bore you with my theory of why people don't like it, but here it comes. Okay? So what we need to do is applications or word problem has something to do with the application of it, right? So let's see here. Determine a trigonometric function to model and solve a problem. Example 1. A town in BC has the deepest natural harbor in North America. The depth d in meters can be measured by the equation d of t. The d of t equals 8 cos pi by 6 times t plus 12. Now, d is the depth. What does the t? T is the time in hours after the first high tide. So, what they're doing here is they're finding a relationship between the depth and the time. That's basically it. Depth and time. So it says here, we are given this equation already. Okay, well that's nice. We're given the equation. The very first one was to sketch it. Okay, well, we're a pro in this. We've done sketching many times now. So let's get started with that. I know that you have this page over here, but I really like graphing on a grid. It's so much easier for me. So if you would prefer graphing on a grid, I have some graph paper at the front for you. You can just pass it around if you need. Grab a few. Okay, let's pass it around. Thank you. Now, before I start on graph, I want to make sure that I have all of the information that I need here, okay? So let's see here. I'm going to actually just use this space to figure out the important information. So letter A, I'm going to do A here. So D is the depth as a function of time. As time changes, the depth changes, right? Is equal to 8 cos pi by 6 times t plus 12. Okay. So what does that mean? Means that amplitude, A amplitude is 8, right? And when we said amplitude, that's from the median to maximum, or from the median to the minimum, okay? Amplitude. Now, this B value is pi over 6, or pi by 6. And the main purpose of that is so that we can figure out the period, right? So we know B is pi over 6, so therefore period is 2 pi over B, and we all know that already by now. So P is equals to 2 pi over 6, and then this is gonna look really nice because 2 pi times 6 over pi, the pi's cancel, we're left with 12. Okay, so what does that mean? 12. It would take, let's talk about that. It would take 12 what? To equal 12 hours? Yeah, hours, because time is in hours. It will take hours for what? For a complete cycle. That's what it means. It would take 12 hours. I should put 12 here. 12 hours for a complete cycle. Okay. Cycle of the tide, right? High tide, low tide, and all that. Okay. Is everybody okay with tides? Okay. What's a tide? Laundry. It's not the laundry. It's not the laundry. Yeah, I know you're joking. So tide is the depth of the water, right? There's a depth. It would go lower, low tide, and it would be high tide. Would be higher water. Okay. So we can Google that later, like what's a low tide and high tide. I'll show you what that is later. So actually, now that we've figured that the 12 is the B, it says here, what is the period of the tide? Period is 12. 12 what? So 12 hours. So that we've actually figured out the B part, 12 hours. Okay. What else do we know about? Is there any phase shift? Any C? Is there a C value? 0. Okay. No phase shift, right? And then the last one, the D is equals to 12. Okay. So the D is equals to 12. 12 what? Meters or hours? Okay, so if this is gone, D is equals to 12. So it's meters, right? Meters, 12 meters. So that means, what does that mean? We start with the 12 meters, that's a median, but then it could get higher, high tide, or it could be low tide, right? But the middle is 12. Okay, so now let's put it together. Yeah, so the question was, can we have negative time? Now they didn't say here, it says sketch of functions for 2 cycles, and we don't have to go negative time, we can just go from 0 to up to 2 cycles. Okay, so here it is. Let's get started. So we know what the amplitude is. Now, before we get to the graph piece, if the median is 12 and the amplitude is 8, what's our maximum? It's going to be 20, right? It's going to be 12 plus 8, which is 20 what? Meters. So that's the high tide, it's 20 meters. Now, what's the minimum tide?
4.
Minimum would be 12 minus 8 would give you 4 meters. So median plus, if you look at this is a median plus A, and then median minus A, that will give you the minimum. I think we have everything. We're ready for your graph. So we have to make sure we have to go up to 20 and we have to go as far down as 4. Can we can go this way. Oh, I already got a grid in here, so if you're using this grid, then that's okay. So this is my 0, so it's going to be 1, 2, 3, 4. Here's my minimum 4. 5, 6, 7, 8, 9, 10, 11, 12. 12 is our median. And then our maximum is 20. So now I know where the median is and max. So I'm just going to put a line here. It kind of gives me, okay, my little boundaries here. Very lightly, okay? This is really not part of our graph. Our median is in the middle. Okay, so I need to go from 4 to 20. Okay, before I move on, is everybody clear on that piece? Yeah? Okay, looking around. So, now that we've figured out max and min and median, now let's do the period. Well, what's the period? It's going to be 12 hours. So, what should we go up by? By 1, yeah. Is that okay? Do we need to go by pi by 6? No, right? Because our period is 12, right? Pi by 6 will make it really challenging for us to do that. So our period is 12. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, look at that. Now, what's our graph again? It says cosine. Well, what does a cosine look like? Cosine looks like just by maximum to minimum to maximum. Looks like that in one whole period. So, one whole period is up to here. There's no shifting, so that means we're starting at 0, right? No shifting. So y is equals to 8 cos pi by 6 x minus 0. Just want to make sure it's all clear. No phase shift. Okay, no phase shift, that means we're starting right at 0. So we're starting right at 0. So in this little box in here, we should be able to fit one cycle, right? One cycle. So max to max. That's your first two key points. Okay. And in the middle is the minimum. Okay, minimum is, it's going to be at 6, but it's going down to the minimum. Is that okay? So I'm going to put the graph right here, max to max. So those are the first two key points, and then this is in the middle, but it's the minimum. So 1, 2, 3. Good. Now where's the next one? So in the middle of this, it's going to hit the median. So where's the middle? The middle is, if there's 12, the middle is 6, and in the middle of that is 3. 3 is in the median. Let's do another one. Another 3, another median. Okay. So from here, we've actually created one cycle. Can we create another cycle? Yeah, we can. And another cycle is another 12 hours. That takes us to 24 hours. Okay. So another 24 hours. Okay, so I'm going to cover that piece. So within this rectangular space, that's where our cosine is going to be. So the first key point is maximum. Maximum. In the middle of those is the minimum. And in the middle of that would be median. In the middle of those two is another median. Oh, that's not good. Okay. Now I'm gonna be really picky here. Okay, as you can see, I'm taking my time to really graph this very nicely. When you're graphing this, make sure on the assignment and the test and on the exam, make sure it's not a zigzaggy line. It's not meant to be zigzaggy. It's meant to have like a curve, right? So make sure it's a curve. So that's it. Are we done? Or are we missing something? Oh, we can keep going, but you only need basically 2 cycles. So first cycle, 2 cycles. What else do we miss? Okay, I'll give you a hint. What makes a good graph? Labels, yeah. So what's the labeling for the x? Time. Time is measured in hours. And what's the y? Depth, right? The d, which is the depth. And it's measured in meters. And then what else? So, title. Yeah, we're going to put a title. The title of this graph would be depth versus time graph. That sounds so, yeah, that's basically very straightforward because the depth varies according to time graph. So we did a wonderful job in creating this graph. It's beautiful and I'm happy with how it turned out. Now, so that's part A, okay? So we did part A done. We did part B because we figured out the period. Now, letter C. It says here, an ocean liner, some kind of a boat, right, needs a minimum of 12 meters to dock safely. Minimum 12 meters to dock safely. From the graph, determine the number of hours per cycle the ocean liner can safely dock. Okay. You know what happened to this Red River, this boat on Red River? What is that called? It's like Red River, it kind of takes you down the Red River and
I mean, the boat, but
the boat, yeah.
oh, I don't know what it's actually named, but it's like a tour.
It's a tour, yeah. So basically, if it's too low, it won't be able to go because it's gonna hit the bottom, right? It has to have the real nice depth to it. So it's the same thing with this. It needs a minimum of 12 meters. So how long, the number of hours, can they dock safely? Minimum 12 meters. Okay, so minimum of 12, so this is 12. And up here is more than 12 meters, right? Do you see that? More than 12 meters. So the question is, how long? That means how long this time. So how long is it able to dock safely? 6 hours, you said? Yeah. 6 hours, because we can count here. 1, 2, 3, 4, 5, 6. Take about 6 hours to dock safely. So I'll go back to this page and I'm going to put 6 hours. Okay, letter D. The minimum depth of the harbor occurs at 6 hours. Is that true? Okay. What is the minimum depth of the harbor? What is the minimum depth of the harbor? What is the minimum depth? The most minimum depth would be 4, yeah. Minimum depth is 4 what? Meters. Yeah, we have to put a unit because 4 has a unit. And at what other times is the level at the minimum? What other times does it hit minimum again? Minimum. Okay, let's take a look at the graph. Let's see. It hits a minimum at, how many hours is this? 6 hours, right? When's the next minimum? 18 hours. Well, stop right there. Does that make sense? Yeah, that makes sense because if the minimum is at 6 hours and then the next minimum is at 18, that's 12 hours in between, and that's our period. Period. And we said period is from minimum to the next minimum. That makes sense to us. Okay, any questions there? Good? It's pretty fun, right? Now let's see this one. Anybody who's never been to a Ferris wheel? Okay, everybody's been on a Ferris wheel. Okay, describe what happens when you ride the Ferris wheel. Yeah, you go up and you go back down, right? So do you start at 0?
Depends on the. Well, yeah, you have to get on. Well, there's like the 3 that like something stuff.
Right, because if this is a Ferris wheel, right, I'm going to put the Ferris wheel right there. Do you remember like stepping, and then this is where you kind of ride?
Yeah.
Right, so the Ferris wheel doesn't really touch the ground. So that means it's a little bit higher off the ground, right? And then you're right, it takes, okay. Now, the Ferris wheel that I've been to, it feels like I'm up, in my experience, okay, maybe it's just because I'm scared of it. It feels like it stays there for a long time, then it goes down. I don't know. But this Ferris wheel, goes around normally. It doesn't stop. The person doesn't pause. Okay, keeps going. So here, the height of a Ferris wheel above the ground follows a sinusoidal path over time. Okay. So what are the two things that we're gonna graph? What are they connecting? What two quantities? Height and time. Height is connected over the time. Y over the x. Right. So its starting point is at the minimum height at 3. So they tell us the minimum is 3. So I'm going to write that down right away. I'll write it down over here because I'm actually going to use a different page for graph. So my minimum height is 3 meters above the ground. And then they said the diameter of a Ferris wheel is 12 meters. Okay, what does diameter mean? Diameter means from here to here, that's the diameter, 12. But it's also from here to here, that's 12. Right? So this is from here to here, that's 12. Okay, good. So diameter, I'll just put diameter is 12 meters. Now let's go on. It takes 16 seconds to make one full round trip around. What do you think that tells us? It takes 16 seconds to make one full round trip. Yeah, from minimum to a next minimum is going to be 16 seconds. And what do you call that? Period. Notice it doesn't say the period of this Ferris wheel is 16 seconds, right? It doesn't say that. But we have to somehow read this line. It takes 16 seconds to make one full round trip around. It's not saying the period is 16. But then we should be able to read that it is 16. Okay, so period is 16 what? Seconds, yes, second. Okay. So, what are we going to do? Sketch the function for full cycles. Now, when you ride the Ferris wheel, where do you start? At the bottom, right? They don't start at the top. This is your starting point, right? So you're going to go from minimum to minimum. Okay, good. What do we have here? So far, this is the only thing that we got.
You can figure out the max height by adding the diameter in line.
That's a good idea. Let's see if that makes sense. So this is where you are. You ride it. You're on a Ferris wheel right there. And then this is the minimum is 3 meters. How far? What's your maximum height? 15, right? Because if you're at 3 here, and then plus 12, which is the diameter, so you're at now 15. So your max is 15 meters. And what's a median? Median would be 9? Yeah. Let's see if it's really 9. Now from here is 3. Now if this whole thing is 12, so that means this is 6, and then this is 6, right? So you're in the median over here, 3 plus 6, and that would be 9. Yeah, okay, good. Median, let's put median is equals to 9. Yeah, 9 meters. What else? Do we know what the amplitude is? Amplitude. How did you figure that out? Amplitude max minus min divided by 2. Yeah, we know that. So we know max, we figured out the maximum is 15 minus minimum is 3 divided by 2. So that's 12 divided by 2. 6 meters. Okay, good. Do you think we can graph this now? Okay. Now we're not going to go negative time. We're also not going to go negative depth, right? So it's okay to just start here. So our median is 9, minimum is 3. So 1, 2, 3. So far so good. I'm gonna stop right here for a second. Before I move on, is everybody okay with this piece? Yeah. So I'm just gonna draw lightly a line this way, a line and a median, so I know I have my boundaries there. Okay. Did we figure out the period? Period is 16. Okay, so what do you think we should go up by? You went by 2? If we go by 1, would it fit? Well, let's see here. 2, 4, 6. Ooh, like for extra 1 right there. Okay. If you went up by 2, keep it. There's nothing wrong with that. I'm just gonna go up by 1. Is that okay? Okay, good. So far so good. Now what I'm gonna do is that you know how like we have one whole cycle, and I gotta be careful in here. Okay, I gotta be careful in here. They said that, that's a question, determine a sinusoid. I'm gonna just read the rest of the question first. Sketch the function for 2 full cycles, determine the equation of the sinusoidal, determine the height of the Ferris wheel above 12 seconds, what is the period of this function, state the limitation on the domain. Now, when we ride the Ferris wheel, what do? We start at the minimum at 3. Okay, so we start at 3. Okay, and then we end at 3. Okay. 16 seconds later, we're at end at 3. Now, what happens next? In between that is in between is 8, and is that in the median or the maximum? Maximum. Okay, I'm going to explain that in a second later. See? Okay. So we start at the minimum, and then because our period is 16 seconds later we're at the minimum again. In between of that 16 seconds we've reached the maximum. What's next? In between again, where are we at? Median at 4, and then median. And over here, at 12, median again. Okay. Now, what does that look like? Okay. So we might have. So it's connected. Okay, gotta be careful. That's 1. Okay, can I do another one? We'll see. Yeah, we'll see in a second. It says sinusoidal. Create a sinusoid, an equation of sinusoid. So that means sine function. So we'll see what the sine function looks like. Okay. So you started at minimum and at minimum. In the middle would be at the maximum. And in between there is a median. Remember yesterday when we talked about equation of the function? We can express the same graph as a sine function, or we can express it the exact same graph as a cos function depending on the phase shift. So this is what the graph looks like. Now, I want to make sure that we really understand this piece before we move on to other things. Okay? So here's what I'm going to do. Okay, this is what I'm going to do. I'm going to create a table of values. This is going to be time, minutes, no, seconds. And then height in meters. See, we want to put the pieces together, that this makes sense and the graph makes sense. We want to make sure that they're connected, okay, that our equation makes sense with the table of values with the graph. Okay, when we first write we call it 0 seconds, right? What's the height at 0 second? 3. Okay, good. Now, here, don't write anything yet. I'm gonna like leave some space in here and then I'll show you why. Now it says there the period is 16 seconds, right? So that means 16 seconds later, so I'm gonna put 16 seconds later here. What's the height? Still 3, right? So that means minimum, 1 around, 16 seconds later, now it's 3. Yeah.
8 seconds is 3 meters.
I can't hear you, sorry.
8 seconds is 3 meters.
8 seconds?
Is 3 meters.
Oh no, it's not 8 seconds, 3 meters. It's because they said period is 16 seconds, so that's 16 seconds later. So you're here, 16 seconds later, you're back down here. That's what period is. Yes? Okay, don't write anything yet. I'll give you some time to write it down, but here, listen, just listen. Okay, so I'm over here. If it takes 16 seconds to go around, how many seconds to go from bottom up? 8 seconds. Does that make sense to us? Right? 16 seconds to go around, so that means 8 seconds to just go up there. So I'm going to put 8 seconds here. And what's the height at 8 seconds? 15, right? Because we got 3 here, and then the diameter of 12, so that makes it 15. Max. Yeah. Okay. Now, if it takes 8 seconds from here to there, how many seconds to go from here to here? 4. Okay, so I'm going to put 4 seconds. And at what height are we? 4 seconds. So it's going to be 3 plus 6, it's 9. Okay, so now we know that a quarter turn will take 4 seconds, right? So how many seconds now from here to there? 12, yeah. You see the pattern? 0, 4, 8, 12, 16. Okay, now at 12 seconds, we're over here. What height is that? 9. Okay, leave that alone for now. I'm gonna go over here in our graph. What's our first point? 0 second, 3 meters. 0 seconds, 3 meters. That works. What's our next point? 4 seconds, 9 meters. Where is it? 4 seconds, so 1, 2, 3, 4. At 9 seconds. Okay, so what's our next one? 8 seconds is 15 meters. Let's see here. Because remember, they all have to agree with each other. You can't have your graph being different from your table of values, being different from your equation. They all have to agree to each other. So 8 seconds right here, 15 meters. And then the next one would be 12 seconds, 9 meters again. And then 16 seconds there. So when you're given something like this, okay, when you're given something like this, start with your critical points. Okay, remember your critical points. Now, I know that it's like you need 5 points in here. So 0, 3, and you know the period is 16. So go up to 16 And that's the same. Half the period, figure out the median. Half that more will give you the median. So, that's that piece. Sketch the function. So we're not quite finished. We did the two graphs, like we did two cycles, but we have to name our x-axis here. So this is going to be time in seconds. And this is going to be height in meters. Okay, and then we're going to call this, I don't know, height versus time graph. Okay. Height versus time graph, and because height varies according to time. Height changes according to time. Graph. Okay, so what we have so far? We have a sketch. We've labeled everything, provide scales. Now the next part is determine the equation of this sinusoidal. Okay, sinusoidal. Now from here, sinusoidal, what does a sinusoidal look like? Sinusoidal is from median to max to median to minimum to median. Okay, so now what we're going to do is we're going to look for where is this point here in your graph?
First one's at 4 seconds.
At 4 seconds. Okay, so here. So if you look at this part here, because we want the sinusoidal equation, we're going to look for where it starts to increase, decrease, back to median. And then this is where it is. Okay, I'm going to just highlight that for a second, see where that is right now. So this is where the sine function kind of starts. Okay. Now, if our graph shifted this way, so what's our horizontal shift? Four, just 4. Yeah, so that means we shifted to the right. Okay, I'm just gonna write that down over here. So here, shifted right 4. So that's the last piece that we need for our equation. Okay, so what's our equation? Okay, let's go back in here. What's the equation? I'm going to do letter B, equation. Y equals, what's the amplitude? 6. Sine. What's the B? Oh, I don't think we figured out the B yet. So we know that period is equals to 2 pi over B. So if we're going to go figure out B, equals to 2 pi over 16. 2 and the 16 can be reduced to pi over 8. Yeah. So the B is pi over 8. Okay, I'm going to put brackets, x. Okay, now our horizontal shift. We said it shifted to the right 4, so it's minus positive 4. Close that bracket again. And what's the D? The D is the median, which is the 9. Right. It's the 9, the median. There you go. So that's the B part. Now let's take a look at letter C. Determine the height of the Ferris wheel above the ground 12 seconds after it started. Okay, well, 12 seconds after it started. We can actually get it from our table of values. We could also get it from our picture. So there, 12 seconds after it starts, that's going to be 9 meters. What is the period of this function and what does a period represent? So the period is equals to 16 seconds and it represents, yeah, the time it took. Yeah, you have to put the time. So the time it took for full rotation, yeah. Okay, and then set the limitation of the domain of this function. So what do you think it should, well, it's not going to go to the infinity, right? Because otherwise it's, you know, it will eventually have to stop. So here we have to set the time from, and you can't go to the negative time starting from 0. Set the time from 0 seconds.
Maybe 32, like from twice.
So we went around twice, and I don't know, maybe we could go maybe 1 minute, I don't know. Yeah, because it's only wrong graph. So this is 32 seconds, like in about 30 seconds you have 2 full ones. So you could probably go for like maybe a minute, right? Or
Well,
6.
we can't have to like go from wherever it's the minimum again because
It has to be the minimum again,
you
right?
can't just stop.
You can't just stop mid-air and then jump right out of the mid-air.
That's why I said 32 because then you're back at that.
Okay, yeah.
Or you can.
Or any multiples of 16, so you can go,
You can talk about supposed to how many times. Like,
yeah,
each square.
how many times it goes. Yeah, that's right. So we can go 32, 48 seconds, so maybe 48 seconds. That's going to give us another, yeah, three full cycles to 48 seconds. Okay, so that gives us 3 full roundabout. What do you think? It's good? Good stuff and then good timing. So we're gonna pause here. We've finished the 2. Later we have some word problems here, or you can spend time on finishing up your stuff and make sure it's handed in today. Okay? Good.